on. That always makes people quiet. It makes us think we're starting, right? Okay, I'll starting. Okay. I'm so excited when my technology works. It's working. Welcome, guys, to the Data Engineering Meetup. I'm so glad you made it. I'm Mariah. If you haven't met me, come say hi after. I'd love to meet you. I run this show usually. Sometimes I'm not here, but usually I am. And yeah, we want to thank Recursion for hosting us. They've got a lovely venue and they provide us food, so give a hand to Recursion. That is Shad and Ayla. Ayla's not here, but Shad is. He's hiding in the back. He's the tall guy. Just a couple announcements. If you haven't been to one of our meetups before, this meetup is a Forge Utah meetup. We have a Slack associated with it. You can join it by going to forgeutah.tech. That is the URL. On the homepage, there is a button that says Join Slack. Just join the Slack. You can join the data engineering channel there. You can join the machine learning channel there. You can join there's a channel for almost every interest. I don't post in the animals channel enough because then it would only be my dogs. But if you're a keyboard nerd, there's keyboards, there's 3D printing, there's lots of home lab stuff. That's been a pretty active channel recently. I post memes and random because I see technology memes on Instagram and I post them on random. And then I cross-post them on my Instagram channel. So please, forgeutah.tech, that's the website. Join it. Join the data engineering channel and every other channel you could possibly imagine. I'm always there. And I'll post about these events or anything that happens. If Meetup deletes an event, which has happened in the past, and it's still going to happen because I didn't delete it, Meetup did, Forge Slack would be where you'd get your answer to that. I will post, still happening. I was hacked again. I was never hacked. It was Meetup itself that dropped the row from the database, so just, you know. After that, we do have next week, is our machine learning meetup. A lot of people here kind of are data general practitioners, so I like to say we have a machine learning meetup. It'll be next week. It's in Lehigh at Weave. It's on RAG, something or another, real life RAG stuff. And our speaker's flying in. We'll be here in person, but not from here. It's Harpreet. I forget his last name because it's hard. Go ahead. Oh, sorry. It is in 2 weeks. It's on the 28th. No, you're right. So this meetup happens on the third Wednesday, and that meetup happens on the fourth Tuesday, but we're in the odd month where the third Wednesday and the fourth Tuesday are not the following week. So it's in 2 weeks at Weave. So thank you so much for correcting me. People would show up at Weave and start messaging me, why aren't you here? It's happened before. And I'm like, sorry, wrong date. So thank you. Yeah. While we're here, jobs. Is anybody here hiring for data engineers? Mariah's company is hiring a data engineering manager. I would report to you if you want me to work for you. I'm sorry. Anybody have jobs that they're, okay, we got one. Will be in the future. Okay, you can
What do I say?
just say who you are and then your company will be hiring. So you can talk about it.
Oh, cool. My name is Kale. Our company, Advocate Aurora, will be hiring some data engineers soon. So if you're in the market, you can just talk to me and plug you in.
It's so people can find you after and you know. We also have a jobs channel on Forge Slack. Best job board in the state of Utah. Way better than LinkedIn. Way better. So, yeah. Anybody else? Any jobs? Any fun announcements? Cool. Then I'll turn the time over to Nick. Nick graciously offered to speak this month. We're super excited to have him. And he's going to talk on data modeling. We do like if questions get asked into the mic just so everyone can hear them. There's that cube over there, and we'll toss it around. But yeah, and it's all you.
All me. I knew this time would come. I've been worrying about it for like the last month and didn't get nervous until the drive up here. But anyway, I am Nick Johnson. Just a little brief bio. For the last year and a month, I've worked at Blue IQ, a little small company that helps deliver analytics out to. It started with chiropractic offices, it's expanded to dental offices, and just slurp in their data and put some cool charts and graphs and add some value to what they're doing and offer an analytics front end for them. I've been working on analytics things for coming up, man, I'm getting old. Had to start wearing glasses even for over 24 years, wearing lots of hats, lots of titles, data architect, data engineer, programmer, analyst. Currently, it's a database engineer. I don't even care what it is. Spent 10 years at Intermountain Health, worked at Jane.com, Adobe Workfront, and my most recent place was All Stripes. That was probably being somebody who was trying to get data into somebody like Recursion. Where we were working on gathering real world evidence data for rare disease research. Got my master's in data science a few years ago, and unfortunately, I almost never use it, but still love reading about it and learning about it. Everything's changed so fast, even since I finished that. And because I can't sit in front of the computer all the time, I play out in the garden as well. So I want to throw this question out. If anybody has any ideas, why do we make software applications? Just what are some quick ideas? The interactive portion of my talk.
To collect data from end users.
Collect data from end users. I like that one a lot.
Automate manual processes.
Automate manual processes. So I'm going to kind of go with one of those, and I want to capture data that can be used for something. So like what Bill was saying, we're going to take in data from users. We're going to use it to hopefully automate that process that they would be doing otherwise. I would also throw in a caveat, maybe if your application is built to strictly display the data that you've gotten from somewhere else, and maybe there's an exception there. But I wanted to talk a little bit about what are some of these use cases that we're going to do for data modeling then. We talked about if you're capturing data from these applications to do something cool with. I've always felt that, and it's been my experience, that when you're taking in data from an application and you want to use it for analytics, and analytics is usually almost always an afterthought. They design the application, they build the application, they go, I wonder how our users are using this stuff. And unfortunately, we get to inherit what somebody else has built on an application level. In a perfect world, you'd have awesome data modeling and you'd have a cool data architect who built the data model that the transactional application database is using. It usually doesn't happen, but I still hold out some hope. What we're going to talk about tonight is more for the analytics use case. And then as we're getting into new use cases, there's a lot of ML types of use cases where you'd probably need to model it a little bit differently than you're going to see in the regular warehouse. And there's a lot of change going on there. And I'm going to put the others in there because surely there's stuff I haven't even thought about. So one of the thoughts, guess I should stay by the microphone. When I was at Intermountain Healthcare, we had this kind of a test. We would kind of teach people this whenever we had a department that had a system that we wanted to start doing analytics on. We said, well, should we bring this into our data warehouse? A lot of these software applications had built-in reporting capabilities, so why would we need to bring it into our enterprise data warehouse? And we came up with the PIES test. And so obviously performance. We had a case where there was an imaging, a radiology system, where if you started doing reports off of that, even doing the extract for the ETL job off of this radiology system to load into the data warehouse would bring the system to its knees. It was just on really lousy hardware. And so to do any analytics, we had to run an ETL job that ran at night once a day, would load it into our data warehouse so they could actually get some performance and so that it wouldn't degrade the performance on the application side. Integration was meaning, say we had, going back to that healthcare example, you have a radiology system. Well, maybe you want to coordinate that with some nurse charting data. You need to bring stuff in from multiple systems and integrate them together. And a centralized data platform will let you do that. And then ease of use. I'm starting to see a lot of really smart data folks out on the LinkedIns and other places on the webs that are talking about why do we need to model data? Why do we need to change stuff and transform it for analytics? And the reason being, a lot of times people think, well, performance, yeah, you get some of these newer data platforms and maybe you don't need to model the data differently for analytics, but your poor users, man, to have them go in, if you've seen some of these data models that we used to have them that were printed out, 4 foot by 3 foot plotted things, and the little ERD squares were about 2 inches wide, and it was just filled with them. These insane data models. And to have a poor user go through and be expected to get some meaningful analytics out of that was just really sad. So if we can model it to something that gives them a good user experience, and we're talking for technical folks, for analysts, got to make it easier for them. And finally, an SLA consideration. When does the data need to be there? Sometimes our data pipelines, if you try to shoot for something close to real time, it gets much, much more expensive. Is it worth it? If you can deal with getting your data hourly or even nightly, then maybe it would make sense to bring it over to a centralized data warehouse. If you need some data elements immediately and truly real time, get those directly out of the platform. So you just need to ask those kind of questions. So just a few things I wanted to talk about a little bit when we get into modeling. Before we do it, we've got to think about the problem we're trying to solve. Mariah and I were having a conversation beforehand during the pizza hour of people just trying to bring up a machine learning and an AI type of an area just because it looks cool. I mean, AI is the new hotness and everybody wants to do it, but you have to think about what problem are we really trying to solve? Does it really require a full-blown formal solution? Think about the questions you want to answer. Put yourself in the shoes of your customers. Talk to them. Find out what they need. And find out who's going to be consuming the model. Do you have analysts or do you have an executive who just wants to look at a dashboard with some canned images, some canned charts on the screen? So spend some time, get it right. I want to talk a little bit about getting into the dimensional model. Just by raise of hands, who's dabbled a little bit in star schemas or dimensional models? Just want to get an idea of my audience here. Okay, about half of you. So I'll get into some pictures. I'm going to actually spend most of this presentation in a data modeling tool. But some of the things going into this is we're going to need to define our keys. When we're loading in data from an application model, so say we're going to hit a use case that I came up with a business case and we'll walk through it. But sometimes so for example, the job where I'm currently working at Blue IQ, we bring in data from a variety of dental offices. What happens if you have patient ID 1 that comes from Dr. Smith and patient ID 1 that comes from Dr. Jones? You're going to have a collision. So what you need to do is you have some identifier that isolates which of these sources you have, and then decouple those keys and translate them to something that's unique. So that and then you need to guard those and make sure they're solid so that you can go back and reload it in a catastrophic event. We're going to get into dimensions. Dimensions are the outliers in your star schema. They're the things that you're going to use to filter on. They can be dates. They can be categories, they can be item numbers, they can be person IDs. Those are kind of the common ones. And we're going to get talking about, and also grouping. Those are the things you want to group by. When I worked for an e-commerce site, we would commonly group things by, what are the clothing categories? Give me the sales of shoes compared to the sales of pants, compared to the sales of t-shirts. And then we're going to have the type 1 and type 2 slowly changing dimensions. I'm pretty sure I got a job once because I brought up these concepts in the interview, and the interview didn't know what I was talking about, and he thought it was kind of cool. So remember this one if you're interviewing. So the slowly changing dimension is basically the idea that if you needed to track something's changes over time and be able to look at what was it last month and what was it today in the same dimensional model. And a couple of ways to do it. A type 1 just says, I don't really care about the history. Let's just update my dimension table with what the current state of the source database is and call it good. For a lot of things, that's probably just fine. We're going to get into a case where maybe we have an item with a price and we want to see what was the price a year ago and the price today. If you want to do a report that's over time, you're going to need to look at what those price changes are over time. And I'll show you the approach to get into that. And then, of course, the fact table, that's the big center thing of our star schema in our dimensional model. The fact is anything we want to summarize. It's anything that we count, that we add up, that we average, that we do math on. They're the cool things. And so a couple of ground rules. It's bad form. If you read the Ralph Kimball book, and I recommend anybody read the Ralph Kimball Data Warehouse Toolkit book. You can Google it. You can usually find a PDF of it for free. It's been out there for a while, but the principles are still good. And I think the pendulum's swinging back to where a lot of the principles are important. But you don't want to have nulls in the dimensions. Basically what that says is if you were to have a UI tool, reporting tool, and you have a user that's going to drop down all of your categories, and you have shirts and shoes and pants and null. What's null? It's just not going to work right. The next thing is we need to decide on what's the grain of our data. So for example, if we're looking at, if we're going to look at clothes in that example, we may want to come up with a dimensional model that takes us down to the grain of categories and maybe months. So you can do math on what's the sum of the sales for the course of the month grouped by different categories. But then somebody else might say, well, actually, I want to go finer grain, have much more detail. It'll be a larger table, but I want to have something where I can actually see it was the pink size small pants, and it was the size 8 red shoes. Each of those might be in there. You have those descriptions and the actual product names in there. So figure out what that grain is, and then your fact table and your dimensions all need to match that same grain, but just decide what your users need. And then speaking of what do your users need, think about what are the questions you're trying to answer. Again, put yourself in the shoes of your user and find out what they are trying to do. And then you can keep the domain of it isolated. There's nothing wrong with having multiple fact tables. When I was working at Intermountain Health, there was I think there still are available. I haven't worked in the hospital systems for a while now, but there were a lot of vendors that would actually sell healthcare related data models. They were pretty expensive, and we were always debating, do we want to buy one of these data models? And they were trying to put everything under the sun, your imaging, your radiology, your surgical, your nurse charting, everything under one model. Man, that model's going to get really confusing. We ended up opting not to buy one, and we just kind of kept these separate subject area domains and built those out to answer the questions of what our business departments needed. So, I did have a slide. I forgot I had a slide giving my examples of grain, but talked about that one a little bit. For example, yeah, you can just decide what those are going to be. There's the examples, date or product or month or category, etc. And I'm also going to recommend that you build a date dimension. You can find lots of things online, how to build a date dimension. At the end, I'll actually give, pretty sure I put it out there. I've got a little script in Postgres. I put it out on my GitHub repo that I'll put a link up there that you guys can get to that'll populate a date dimension and you can play with that. And the nice thing with that is it gives you all of the dates as your key is this calendar date. And then it also has like weeks, quarters, months, years, a little indicator of if the day is the last day of a quarter, the last day of a week, the last day of a, you name it. So those kind of things come in really handy for allowing you to group really simply. Auditing, always have update timestamps. I'm working on a system right now where as people brought stuff into the database, into the analytics layer, there is no audit trail. I cannot tell when records came in, and it is really frustrating to troubleshoot. The classical approach, you have to populate your dimension tables first before you can populate the fact tables. And if we have time, I will talk about a way that we can populate these in parallel. Cardinality, the relationships between the tables, one to many, many to many, one to one. You need to think through those kind of things. And also on an analytics platform, don't enforce the key constraints, the foreign key constraints. A lot of the newer analytics data platforms don't even allow it. I know Snowflake it's a fairly recent development. They will allow you to enforce a not null constraint. And that one actually I really like for data quality purposes. But they will let you define a primary key constraint, but it's just for information purposes. And it may help them improve the query plan, but it's not enforced at all. In your application layer, yeah, I'm a big fan of that, but to ensure the cardinality and everything is kept correct. But on your analytics, you're going to run into real trouble if you start doing that. You need to reload different tables at different times. So, okay, we're going to get into the fun part here. I came up with a business case. This was like the longest part of preparing this presentation was getting this data model. I want to walk through this and even thinking through what was a cool business case that people might be familiar with. So this was a very simple one of, thinking like, DoorDash or Uber Eats. Just decided, to keep it simple. We've got customers, restaurants, there's categories. Yeah, you can read what those say. But doing that, I'm going to switch over to my data modeling tool. So the tool I'm using, this is called DB schema. I've used, let's zoom in here. And I like DB schema. It's not the most expensive tool, but it allows you to create the tables. You can reverse engineer. You can connect to a database, reverse engineer the schemas, bring it in, modify them. It'll write back out to the database. Don't do that. That's scary. But it'll spit out the create table statements, create index, and views, materialize. It'll do all kinds of cool things. I do like it. It's more than just the visualization, but I think it's mostly the visualization stuff I want to show. Oh, and it'll spit out some nice documentation and PDFs and markdown and things too. But this is the transactional model I wanted to show. Is that large enough that you guys can see it, or shall I zoom in on some of the pieces as we go?
We can even read it on the back row.
Wow.
And that's with the old eyes.
That's not bad. I still have to use mine to see it up in the front row here. So as we can see here, I just want to talk about a driver can make multiple deliveries. Just watching this cardinality. I don't know if you guys are familiar with this crow's foot notation. The one over here means, or that vertical line means it's one to one or many. So the crow's foot means many. The line is one. A delivery can deliver one or many orders. And an order can, come in the other way around. Let's start up in this lower right area, a category. So the category would be like, pizza or burgers or something like that. A category can have many restaurants. So you have lots of different taco places. A restaurant can have many menu items. And then a menu item can have many orders associated with it. So in other words, lots of people can order a pizza. And I've got the quantity attribute in there too, so it's and the price. It's also important to note here, one of the things we did in this model is we have a menu item price, and then we've got it's at the menu item level where we have the item prices, but it's the order where we're going to have the quantity that they ordered and then the item price. It might be a little different. The reason we do this is this would allow us to, you could do like a discount or something. You'd say, yeah, the menu item, it's $5 for a burger. But over on here, maybe we said, the application could say, oh, the item, we're actually going to charge them $4 because they're a frequent shopper or something. Anyway, then of course, an order can have the customer order. And this is where we start getting into the customer field. So this customer table, this customer order table, when you see these crow's feet coming into this one table, this tells us this is a bridge table or an associative table. It's another term for it. What we're trying to do is, what we're saying is an order can have many customers and a customer can have many orders. And it's like, well, that can get really confusing. How do you resolve that and manage that? Well, the answer is you use this bridge table to resolve them. And that just tracks which order went to which customers and which customers went to which order. And it breaks up that many-to-many relationship into a couple of one-to-manys, many-to-ones. Then, of course, we got the delivery locations. For application purposes, we'd say, hey, a customer might, for our meetups, we might be delivering pizza to Recursion, but sometimes we might have to have the meetup at a different location. So Mariah probably has a few different locations in her delivery profile.
Yeah,
Yeah.
it's true, I do.
I was thinking, yeah, that's probably a case for Uber Eats. I'm just guessing. And then for a specific delivery, well, that delivery needs to go to a specific location. And so there we are. So going on to that, oh, I forgot, I'm not on a slide. This is the actual tool. So the goal is, here's the mission impossible, if we choose to accept it, is to go from this transactional application model that the business is going to be using to run their business to something that we can use for analytics. So I'm going to do let's see, this one. Oh, there was a Zoom somewhere. I wanted to talk a little bit about the grain. And part of doing this grain, in my slides, I talked about, let's come up with some of the questions that a user might actually be interested in. I figure, well, somebody might want to take pictures, sorry, I saw somebody taking a picture of. Somebody might want to do a summary of sales by date. You'll notice here we've got this date dimension I talked about, and it's being reused multiple times. We use the same date dimension to talk about order date and let's see if we can expand that a little bit so you can see it better. Delivery request date, because you can put in an order and say, well, I don't want that delivered until Monday. And then the actual delivery date that was actually completed. Maybe you'll have some orders in there that never had a delivery date. Maybe they were canceled or the driver got lost, because I get lost really easy. And you can break it out by food category. So just a few of those kind of things we can talk about. But one of the things we're looking at this grain is, you'll notice on this one, I do not have a menu item area on here. We have this summarized to the delivery level, and that enables us to do things like the tax and the tip amount and the delivery fee amount. So I'm going to go back here really quick. This tax and tip, so you remember those were part, and the delivery fee, those are part of the delivery. They have nothing to do with a menu item. And so if you wanted to say, well, how much delivery fee did we make on deluxe tacos? Well, I don't know. It was kind of a group thing. It was with the whole order of a variety of different combinations. So really, our data model on the application doesn't even support breaking that out. Now you could come up with some different methods. Maybe you'd say, hey, we'll just divide it evenly amongst the orders. You know, it's a business decision, and you can definitely do that. But otherwise, those are metrics that are only available at the grain of the delivery. So that's why I called this, I don't know if you can see that at the, oh, I guess up here. This is the delivery date grain. We have it at any date down to, it's not summarized to a quarter or anything. I left it at the full date, but it's just at the delivery. So then if we wanted to do something at the, let's go a little larger there. If we wanted to do something at the menu item grain, I've added the menu item table down in the bottom. I threw in here just for illustration purposes. Otherwise, the model's all the same, but I have this tax amount, tip amount, delivery fee amount with a bunch of stars around it. Those are to say, hey, no, you can't do that. It's the wrong grain. So these actually I would not include in the model, but I just wanted to put them there to highlight that, to say that's a no-no. If you did want to do that, though, like I said, you could say, you know, there's some approaches that you can do to sum them up and divide them by a number. It's tricky to do, and it's typically not done. Oh, so I had a thought on that. I forgot it. Anyway, it just comes down to what's that grain, what's the level you're reporting at. And this is a case where maybe we have two different dimensional models, one for delivery metrics and one for food metrics. Oh, I know what I was going to say is if you left this tip amount and tax amount and delivery fee amount in the model, what would happen if when you started reporting on the data and you started summing up the food or any of these amounts, the tip amount or the tax amount, you would get duplicates and you would end up severely overstating your data. So basically, if it was $5 for a tip, you would end up counting it as if you had your food items in there, you'd end up counting $5 for a tip for every single taco. And obviously, it was really the whole order. And so you'd end up with these ridiculously high amounts, and your users are going to come and say, your data model stinks. I'm not going to use it anymore, and get out of here. So data trust is huge. Oh yeah, that's my one-liner. I was going to say, I don't know if it even fits in here. What's the one thing that's worse than having no data? This is like a data quality and data ops kind of thing. The thing that's worse than having no data is having wrong data. So now I wanted to get into, oh yeah, and I think I'm doing okay on time.
Great.
Sweet. I mentioned in their type 1 and type 2 slowly changing dimensions. And what I wanted to illustrate here, and actually before I do this, were there any questions on these grain, delivery date grain and the menu item date grain, these models? Yeah. Let's go you first and then over here.
With the from the back menu, actually, can you go back to the transactional model that you have?
Yes.
So between order and menu items, this is kind of brought up in the other one, but I'm kind of curious if, like, I would think that if you had one order ID, you could also have many menu items associated with that. So so would that really be, and I don't know if it would matter, right? But would that cardinality be like the crowfoot on both sides?
The other direction?
Or what?
So what this is saying is if you have a menu item, so say the menu item is really just a list of and let's make the universe really small. We're a pizza place and we sell cheese pizza and we sell pepperoni pizza, and that's the universe. This table on menu item is just going to have 2 rows in it. So those 2 rows can then be reflected over in order. And you're going to say that the Bob ordered 5 pepperoni pizzas and Jill ordered 3 cheese pizzas and so on, and Frank and Henry and Jill and Martha, and lots of orders over there. And so that's the reason you have it's the number of rows is kind of really what you're looking at in there. So you have the low number of possible items over here in the menu item, and in the order is where you're going to duplicate that many times.
Yeah, that makes sense. When I was in class,
Mhm.
I would always get confused because they would go the other way too. They would say for one order ID, you can have, that one order, right? You've got multiple, you've got
Yep.
cheese and the pepperoni.
Oh, okay. So what we've done here is you can have that in a given order ID. So the way I've defined it in this case is we said an order is a single menu item. And then we went over to here to the delivery, and then the delivery. So this is actually what we're talking about with the crow's foot, 2 crow's feet coming in. Order is actually an associative or a bridge table saying exactly what you're trying to say, that we actually have many deliveries can have many menu items, and many menu items can have many deliveries. So we're resolving that by using this order table, and the order is actually that bridge table. So all we're going to say in this order table is we have a menu item ID that tells it, yeah, we can have many menu items. Maybe I came in and I ordered a cheese pizza and 2 pepperoni pizzas. But then over here, I needed that delivery. And so that delivery is going to be the delivery ID. And so that it's one delivery. We delivered that order of 1 cheese pizza and 2 pepperoni pizzas over to recursion.
No, thank you.
Is that helping?
Yeah, it's
Little
just, it's something that I would always get hung up with.
Yeah.
If you look at the model and you're trying to say, okay, the cardinality, you say, 1 to many, this way, does it go the other way? And really does it matter? Where would it really get you hung up? Because sometimes I look at
Yeah.
the diagrams, I'd be like, well, what is it this? Should it be this way? But does it really matter?
It usually does matter, but yeah, you can get hung up with it. Yeah, the telltale sign that is going to drive this, that I think, is to take that step back and see, yeah, do you have any associative tables going on here, any bridge tables happening? And then that'll clarify. And then you just look at what's on the other side of those associative tables and you find out, oh, that's really where the many to many is. If I was to get rid of the order table, I would have a crow's foot going into delivery and then a line straight over to menu item and a crow's foot going into menu item. So yeah, we head on over here.
So I understand this as the transactional model is like, that's the source of truth of everything behind the scenes. Try to drill up and drill down and ultimately get to whatever piece of data that I wanted out of it. So the analytical models, are you suggesting that you're duplicating the data to make that the analytical models, or are you using views, or what's the vision there? So
typically in an analytics use case, the application is going to be running on a production system that's optimized. It's going to be on a SQL Server or MySQL or Postgres, and it's going to have the indexes that are optimized to return 1 row at a time. And a lot of times those things get hit really heavy. If you start running a query on that same hardware that is now trying to summarize all this data, logistically, yes, you could actually put an analytics system on the same box. And there are some cases, Single Store is the vendor that kind of started it, and then Snowflake, just at the beginning of the year, I think it went GA. I'm trying to remember what they call it, but they've got the same kind of thing where you can actually put them all on the same box and the same system. It's pretty cool if you have that use case.
So your vision of this is kind of OLTP versus OLTP.
That's exactly the difference. That's exactly it. This transactional model is the OLTP, and then everything else is the OLAP. Yeah. And yeah, so it's really just it's a performance reason. You go through that PIES test and see what makes the most sense. and how you're building that out. Any other questions on these ones before I jump to slowly changing dimensions? Or how slow are they? So let's talk about the type 1 slowly changing dimension. This is the one where I don't care what changed over time. Where I want to focus this one is down here in the menu item. I suffixed it with just a slowly changing dimension 1 just to make it a little easier to see. Created another fact table just for illustrative purposes here. But we have a menu item, and the menu items, they're going to have a price in there and they're going to have a description. And over time, maybe we'll change the price. And that's very likely that a menu item is going to change prices over time. Maybe the description will change. Maybe instead of using American cheese on the burgers, you change to cheddar cheese or something. So anything in that dimension can change over time. In this case, we're saying, let's not worry about those changes. Let's just capture the state that it is today, the last time we ran the ETL and populated this table. This makes life really easy. You don't have to worry about managing and tracking these changes. But of course, in your analytics use cases, your customers are kind of limited on what did the universe look like 2 weeks ago or 3 months ago or a year ago. It just simply updates the dimension with the new data values. I was going to show, let's see if I can get this to come up in the right place. Not this one. Sorry, you're seeing my work screen there. Don't save it, I just want the other one. Okay. If we were to populate this table, this is the data that's all available in the GitHub repo that I'll give you guys the link for. But if we wanted to do a dimension for the menu items, slowly changing dimension 1, is that large enough, or I'm going to zoom in a little bit? Come on, how do you do it without my mouse? Hey, there we go. So what I'm going to do is, of course, regular insert statement, just try to keep the math easier. But say in our system that we've got coming in, so say we did some kind of a batch system and we have we used to call them in the old days, an operational data store or ODS. As data got bigger, they used the same concept, but they started calling them a data lake. Same thing, you have your dump of your raw data sitting somewhere. And so say you would store all your dump streams of data or your batches of event data over there. It's kind of what we're imagining this is coming from. And when we're going to populate the dimension for the slowly changing dimension, the type 1, I don't want multiple rows in there. So if I had a record in there where a taco is $5 with item number 1, and then item number 1, the taco is $6, like, well, that's going to break my primary key constraint. Even though I'm not enforcing it, I don't want 2 item number 1s. That's going to really cause problems. Which one is the correct price? So what I'm doing is, and a lot of you guys have probably seen this, I'm just doing that old trick where you say, give me the row number window function, breaking it out by the menu item ID. And I call that row num right there. And then I'm just going to wrap that with an outer query and I'll just say, filter it to where the row num is 1, sorting it descending. So what that's going to do, it's just going to give me the latest version of the data, throw away the rest of it, and only throw that latest version into my query. Or sorry, into my dimension table. And then one other thing I want to talk about, and this is the case, remember how in the slides I talked about no nulls in your data or in your dimensions? The way we fix that is when we're populating all of our dimension tables, you can union all a dummy record that'll join to any of the unknowns. So what you do is you say, if there's, you just throw a row in there, you can put unknown as the menu name. I like to just do, if this doesn't conflict with any of my item keys or anything, I'll say -1 for my key value. And just put some bogus date way up in the future. And then of course my audit record just has a now function in there, just give the current timestamp. So anyway, this is how you're going to populate the type 1. You're just going to get the latest version of it. Any questions on this one? Or jump into type 2? Okay, type 2, slowly changing dimension. This is where I'm going to go into the strategy we're going to use here is we'll use an effective start date and an effective end date. And so what we can do is say, going back to that example, so say the taco was $5 last year, now it's $6 this year. So our start date might be, okay, January 1st of 2023 would be our, get that thing out of there, would be our effective start date value. And then the end date would be December 31st, 2024. And then the next row, you're going to have the start date be December 21st, 2024. And then the effective end date, well, what do? We haven't come to the end of it yet. And you don't want to have a null in there. So what I usually do is just pick some date and make it consistent throughout my analytics platform and just pick a date way out in the future, in 2399 or something, December 31st is a nice solid way to do it. And then what you do is when you're trying to query the thing and you say, I want a record that is, I want to sum up all of my order or, the menu items. I want a count of all of the tacos that were sold and the sum of the price they paid for them between January 1st and March 1st. You can join on that and in your query, take advantage of these start date and end dates. And it can be a little slow. That's the downside. That's the trade-offs with the type 2 slowly changing dimension. 90% of the time, maybe 99% of the time, I don't know, 42% of all statistics are made up on the spot. But a large percentage of the time, the use case you're going to need is just the current record. So what I like to do is because I've picked that date way out in the future, I can actually use that as an indicator to say what's the most current date. And I can put a view over the top of this that says, give me just a view that we'll call it just the dim menu item current. And the dim menu item current would be just select star where effective end date is December 31st of 2399. And so that allows us with just a view over the top of it. You don't have to rematerialize all the data every time. It gives us that really easy way to find the currently active data. So, and then just a quick, come on, there we go. And here's how we're going to insert into that slowly changing. This is actually the insert into the slowly changing dimension type 2 is actually a lot easier. I don't even have to do the where row number equals 1 or anything like that. What I am going to do though is a lead function. I'm going to say, hey, give me what the future, what the next value is, and that's going to be my end date. If we scroll over, I should probably put some carriage returns in here, but it's the end effective date. I'm just going to say, give me the lead, give me the next value. And I do use a coalesce, or if you're come from an Oracle or a Snowflake background and a few other flavors, use the NVL. Same thing is basically saying if that first thing is null, so if the next value doesn't exist, then throw in 2029, December 31st. And boom, there it populates it for you. And then of course, I've got my dummy record. So I'm gonna go a little bit deeper. What happens if we have more data to be added? I might let some of you guys just kind of explore this on your own. This is going to be available. This whole code is in my GitHub repo. But I created another view over the top of this. that just simulates some of those records being, additional records being added to it with a change in price or a change in description. And the way we would, just wanted to illustrate those a little bit of how you would add those to our slowly changing dimension. And it really doesn't even need to change much. So, yes.
So I'm just curious, you have the price, exact date, price, and rate.
Mhm.
So for example, there's something wrong, like somebody report a value, in wrong date. If I need to fix that, or not causing a lot of problem, I have to go through a lot, try to make sure they was following the right interval.
So that's going to depend on how you do the ETL process. The classical way to do it, and this is kind of the Ralph Kimball approach, and when you're having smaller data sets, is every time you run your ETL, you're actually going to blow away your whole dimensional model, your facts and your dimensions, and rebuild them. Obviously, you would do that off to the side and then rename some kind of strategy so your users wouldn't be without data for a little while. But yeah, that would give you an opportunity to fix it. The more complicated case is when you're doing an insert-only approach. I mentioned in the bio a little bit about Data Vault 2.0 modeling. And that's an insert-only approach to getting the data in there. The nice thing, if you do it right, you can just add new data to it, and it would have a newer date, a newer insert date. And so it would just grab those kind of things. If you made a mistake in there, you got to kind of think about what are the prices. I had a case several years ago where we had they say storage is cheap, but I argue that, yeah, it is, but processing is not. I had a process at Intermountain Healthcare. I had about 10 years worth of nurse charting and pharmacy data coming in. It took about 8 hours to process it every night. And there was a bug, a hiccup in the data delivery that happened for about 4 hours at night for 2 weeks before we noticed it. People wanted that data, but it's like, this is going to take us a month to repopulate all that. And we just opted to, we don't care anymore. It's just not worth it. It's such a small snippet of data. So it's trade-offs. It's all about trade-offs. So yeah, please.
So on OLAP environment, do you create a views on the database itself to populate what the end user needs?
A lot of times I do. I'm building one out in Snowflake right now, and I have views and even sometimes some views on top of views. And part of the big reason I do that is I can change, oops, sorry. I can change stuff under the covers. I can change how I'm calculating a field or how I'm coming up with that effective end date or something like that. And it doesn't affect what the end user is seeing on there. They have that view, it's static, all the field names are what they need to be. And I have all kinds of flexibility under the covers. I can have 12 layers of other views. I mean, that's be a terrible performance thing, but I could have a view on top of a view on top of a view, and then finally the customer facing view. So I do like, for these analytics cases, I generally do like having a view available to them. Another benefit of the view is if you're loading up tables. So say you have your production table and then a view on top of it, and then you need to load up another table at night when you're doing your nightly ETL. You can build up a separate table over here. This one's feeding the view. This one's getting populated at night. Once it's done, you just change your view definition to suddenly point to this new table. So there are a lot of advantages. I do like creating the views over that.
It's easy to maintain the views.
Usually it is. I haven't had any problems with maintaining. I mean, come up with some solid scripts, make sure that the things you're doing regularly, you have in your you have a nice catalog of what your views are going to do. If you have an orchestration tool, if you're using, there's getting to be so many of them. I was a big fan of Airflow. I still use Airflow, some of the others. But you can just add in your script as if you need to do things commonly, you just run them.
Store procedure, that's how you create them.
Sorry, the what precision?
You use a store procedure, that's how you keep the view table consistent and
Sometimes I'll do either a stored procedure. It depends if you want to put your business logic in the database. Some people don't like to do that. Or you can store them out as just SQL files or Python files if you're using like an Airflow. And either way, I very, very highly recommend if you have a stored procedure, the code that creates your stored procedure, put that into a version control repository, or if you're doing it in code, in traditional programming language code, put those into a repository as well. Even the SQL statements. A common way you'd probably do this is have a templatized SQL statement. So you'll have, all your SQL in there, and then maybe the date ranges or the names of your database or your schema name. This was a common one we'd have is you'd put a Jinja template on it. So in Python, I think several languages have some kind of a templating thing where you can just put a placeholder in there that says the database name, for example. That way you can run the whole thing and replace the template little spots with a link to the name of your production database or your dev database, your test database. So I don't know if that kind of went off the side a little bit on your question, but is that Mike?
How you build all the views on top of the OLAP and keep it as a regular job running and modify it. So it's very flexible to those inside.
It is. The views are very flexible, and that's just the power of them. It gives you capabilities. It depends how mature your shop is. If you just have a few people and you don't have a lot of automation going on yet, well, if you own the database, if you kind of wear the hat as a database administrator, you run those scripts when you need to. If you have a very mature automated set of processes, well, you can automate all those shifting. I mean, the more you automate it, though, the less you have to get woken up in the middle of the night. So that's the key to that one. I think that was what I had in there. How are we doing? We're almost at 8. So the slides have some of those. Oh, I promised I would tell you a little bit about some concepts of Data Vault 2.0. So Data Vault is something that was kind of invented about the same time as the star schema, as Ralph Kimball came up with the star schema model. The problem with Data Vault is we didn't have enough compute to handle it back in those days. Now we do. And they've taken Data Vault 1 to Data Vault 2. There's a lot of good papers on it. The guy that invented it, Dan Lindstedt, he's got a lot of great papers on it. He's since put them behind a paywall and harder to find some of them, but you can find a lot of information on it. So there's a lot of books out there about it. Snowflake has a couple of evangelists and some great papers. What's his name? Patrick Cuba is the guy's name at Snowflake, and has some fantastic papers on how to do Data Vault 2.0. But one of the things with Data Vault, or a couple of things, you only have to worry about insert. You don't have to update, you don't have to merge, delete. It's insert only all the way. The other thing is, remember how I had those source keys. I talked about having maybe a customer number. You have customer 1, 2, 3, 4. And that's great until you have another system where you have customer 1, 2, 3, 4, and you're trying to integrate them together. And you get into trouble because you have to figure out which one what's your primary key going to be? Well, you have to have yet another table to kind of manage the translation between what's the source system and that customer number. And then the other downside with that is when you're populating the dimensional model is you have to first go through an exercise of figuring out what that mapping is. Then you have to populate your dimension table. So you have a dim customer, you have to populate that and figure out what all your customer keys are. Then finally you can populate your fact table. And so it's going to take you twice as long to do this whole exercise. With this Data Vault approach, you can populate them all in parallel because you know what that customer key is going to be. So in this case, what it does, the whole idea is you're just throwing an MD5 hash over it. Whoops. The yes, there is a risk of collisions, but it's a very small risk. So in most use cases, it's fine. And maybe some cases where you absolutely positively no way, no how can ever have a collision or your head's going to get torn off, then maybe you don't want to do this. But otherwise, the MD5s, the collisions are so rare. And what you're going to do is you're going to concatenate the source key. So maybe this was that customer key number 1, customer key number 2. And I'm going to convert it to a string. And if by some odd chance it happens to be null, put in the text -1. Put some delimiter in there, concatenated to it, and then a source system identifier. Convert that to a string in case it's not a string, throw an MD5 on it, and boom, there's your key. It's not very human readable, but usually you don't throw, these keys are not something that you expose to your customers anyway. Usually the keys are internal for all the joins, but the customers usually don't need to see them. So it's okay to have this ugly looking hex value on there. This other MD5, this is more getting into the depths of Data Vault. I don't know that we want to go into that tonight, but it talks about, you'll see what this hash diff is doing. It's looking essentially for a difference in one of the fields and allow us to very quickly compare if there's a change in this new incoming record or a record we already have. If there's a change, we can insert it. If there's not a change, we can just throw it on the floor because we already have it. And but yeah, that's basically the thing from Data Vault. I've started doing that upper approach though, of just using a hex value for the an MD5 for the key, and I can load everything in parallel. And that gives us the questions piece. I'll leave that up for a second. You guys can get it. I don't know, Ryan, do you usually distribute slides or anything like that, or?
Just feel free to post it in the data engineering channel on Forge.
Okay.
Or in the live Meetup channel on Forge. That's typically how I do it. Other people are like, just check out the GitHub. Anyway, yeah. If you want to post the slides there, that's usually where I direct people.
Okay.
And then
I'll throw them in there.
GitHub also. So yeah,
I can do that. I've got the data in there. I'll throw the slides in there as well. Then it's
that'd be great.
to one place, and there's the link to it. Oh man, I was hoping this would come up. This is what I get for rebooting my machine. Have any of you guys ever looked at Metabase, an open source BI tool? This is like the second time I've played with it, and there's a problem displaying the charts because I rebooted my computer before I came. But Metabase is nice, and you can set up it's a nice BI reporting tool. I was hoping in here I could show you guys the data that we have, and maybe it'll let me browse the data. Yeah, here's the DIMS. I took all this stuff, and there's a script to let you guys do the same thing in the GitHub repo in a Postgres database that I've got running here. But yeah, you can see what the categories are. And I went through and I created all of the joins, all the links, and everything already. Maybe I didn't start the Postgres server. Well, given our time is kind of long, I'm not going to worry about this one, but know that you can do this. And it's a fun way to do it. But any other final questions before I sign off? Yes, in the back.
Yeah, so I've done, built some models in the DBT and but Snowflake and stuff. I've never used one of the modeling tools, like the visualization that you had.
Mm-hmm.
What role is that? Is that like, you use that as like a source of truth? Is that like any of the code, or is it just like something you build separately to visualize for your team? Or yeah, what's the role of something like this?
I look at it as a design tool, as a technical data design tool. What I really like about it is I can connect to a database. I mean, it just uses JDBC connections. I can connect to whatever database I want, and then I can reverse engineer and I can tell it, give me the schema. I can pick a database and a schema out of it, and it'll pull whatever's defined in the database. Sometimes you're lucky and you have all these foreign key constraints in there. That makes life nice. That's not usually the case, but whatever's defined in the database, though, it'll slurp it all in and give you a quick visualization for it. Then I'll take that, it can move these boxes around. The other thing that's really handy with it then is so say I wanted to just take this dim location, and I'm going to need these again. You build the SQL. I can say, why is it not going to work? There we go. Give me the create statement. And it throws at the bottom or create table, all the constraints. It'll do this for the whole database, and it'll actually connect to the database and make the changes there. So you can use it as a database maintenance tool. Gets really, 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 really scary to do that against a production system, because if you accidentally delete something here, it'll wipe it out of your production system. You don't want to do that.
Just a comment, I think, for why there's a lot of value in taking, I mean, this whole talk is about taking the design script, right? So I'm not to devalue your talk, but the real world experience came up at work literally today. We have this ID on a table called transaction link ID. And it's supposed to be a unique ID, but nobody knows what it links to because there's no system-wide documentation about what the value is. And that's what I see coming from something like this, is it's not just tables, it is across the entire system of multiple data storage or multiple databases. This ID can relate to these things. And you can know, oh, this ID is supposed to be unique, or this ID is supposed to be used for lookup. This might be whatever you call that order table, where it's like a bridge table. Like, I think, I don't, again, whether you generate the SQL or not, like, ignoring how you implement the thing, the documentation value alone helps people 2 or 3 years down to be like, oh, that's why they have that ID there. So when you're trying to migrate from one data store to another, like my team is doing, and you have this magical ID that you have to have that has some meaning, you don't have to go figure out who worked on it 5 years ago and created that ID. So like, if nothing else, whole reason to architect your data and to create these is so that when somebody else has to go and fix your system, it exists. So that, in my opinion, the real world use case for it.
Yeah, and this,
That's what, anyway, sorry.
yeah, and this one's really nice too, because it will let you, you can spit out documentation, and well, the file itself, the data file here is all XML, so you can, it has Git integrations. So say I wanted to do this cool output, come on. So what I just did, or what I'm doing here, is I'm generating this nice documentation that you can then publish out to your company. It has all your visualizations. It has, if I had populated descriptions on everything, has everything on there, displays all the foreign keys, all your data types. And this is where it really gets powerful.
Nick, if I may.
Yeah.
And this is the PDF version. It also produces an HTML5 version that's interactive.
Mm-hmm.
And as you hover over things, it highlights stuff and jumps to foreign keys and jumps to sections of this document.
Yeah.
It's really awesome.
It's really nice tool. I really like this. Do you use this tool?
Yeah, to amend what Mariah was saying in answer to that question, it is a fantastic communication tool. It's fallen out of favor in the last 10 or so years as developers kind of took control of data modeling with NoSQL and so forth. But it used to be that when new employees or managers would start at a company I was at, they would ask, where's the ERDs? Because it helped them to quickly grasp the scope of a system or a business and understand how things are related. There, as you're modeling the entities and attributes, there's a space in the modeling tool that allows you to document what you're learning about the thing from your business analysts and your subject matter experts, so that you don't lose that over time as well. And those get automatically generated into comments in the database where they're much less likely to get lost. Now, humans still has to keep it up to date, but anyway, it's just a fantastic tool. Another thing that's really great about them is that visualizing the scope of your database, you can immediately see if you've got circular dependencies or missing foreign keys you thought were there. If you're just looking at a DDL spew out from a database, it's
hard to read.
You're human. It's hard to read it all, but seeing it visually, pictures worth 1,000 words, it's just a great tool to incorporate. Now, this one in particular, I've been evaluating data modeling tools for 25 years. Used to publish stuff, and ER Studio used to win hands down all the time. Then Irwin came back with a award. The last time I evaluated, my company is not willing to pay for either of those two because they're pretty.
Those are really pricey.
Last time I bought this, it was $180. It's $50 a year to maintain it. It's the only piece of software I actually pay for personally. just because I love it so much. It natively connects to like 50 databases.
Yeah.
Dragos is really personable and quickly fixes anything you find.
Yeah, I've submitted bug reports to them and they're snappy with them. In fact, I think I have another one I need to report to them, but yeah.
You mentioned earlier that you used to really love Airflow as an orchestrator. Is there an orchestration framework for after the data pipeline, swapping out the view, or for any orchestration that you prefer these days?
I'm a Snowflake fan and they've been building out, they've been building out some internal tools, what they call them, just call them tasks. And a task can have subtasks, so you can kind of build out a DAG there. It's not going to be quite as customizable as what an Airflow can do. I know there's been a bunch of them. There's blanking on the names of Airbyte is one of them. I forgot some of the other ones. I haven't played with those yet. So
There's like Prefect is a common one.
Yeah,
Dagster is
Prefect,
another
Dagster.
one that I really like because it has nice integrations with like DBT if you're using DBT, or like it's a little more asset data engineering
Yeah.
focused, right, in that sense, where it's asset based. That's a nice one, honestly. But there's a whole bunch of other ones now too. Mage and I like, yeah.
in the old days, we used to use Informatica was the really cool one that everybody had to have. And there was Data Stage that IBM owns now. And I used Data Stage for years, but I don't know, the open source world took over. And I think those old proprietary ones just kind of lost a lot of favor. And they're both really powerful. Some of them, you have to really know what you're doing and to be able to code up. I mean, I'll admit, building out custom operators in Airflow really honed my Python skills. And so there's just trade-offs. Some of them, it's all GUI. Some of it, you got to code. Let's see, you had a question back over here. I didn't get to yours. Do you still have it?
I just want to find out what the name of the tool.
Oh, yes. This is called DB schema. I've also used, what was the other one I used a few years ago? It was purely online, SQL DBM. I don't know if you've played with that. That one was pretty decent too. It's a cloud offering. So this one is nice. You have it on your local machine. If you don't have a network connection, you lose it. The other thing I really like about this one, depending on the license you choose, if you choose the per seat license, you know, it's actually the cheaper one. If your license expires, you can stick with that version you've got indefinitely. So, but I am going to call it.
If you have any other questions, feel free to grab me after. We are